Okay, so let's start our sessions today. We will discuss the midterm questions today. Mm. So let's go into the first question. You can see the screen, right? The share screen on the midterm questions. Okay, so for questions one, they are asking to modify the program so that you're adding two numbers. So what is the content should be inside a memory? What should be the content inside here? The memory. The content in the memory should be the same until the last step, right? So what should we do? Instruction and data. So we go for the data first. So or we go to number first. What should be the number? This number. What should be the number beside your instruction? Address. So they should start with 220. They start at 220, right? So there should be 220, then followed by 1222 and 450451. Right? Okay, then the content inside the memory for 220. Clear? They told you the instruction address start at memory 220, right? One should be 221. The next one should be 222, right? Follow the sequence. Then they want to add two numbers, which is the address is 450 and 451. So the two numbers should be at 450 and 451. And 451 should contain what kind of data? What is the number should be inside? What data? What should be inside here? 450 should be your hexa number 15, right? So it should be 0015. Then your right, they're given in the questions. The next one should be 4B, 004B. Then the instruction, they ask you to add two numbers. So if you want to add, the first thing you must load the values into the accumulator. 20 should be a 1450. One four five zero at 220 at 221 at 221 should be hexan. The opcode is 1, means you load something into your AC. Okay, so you bring the data and location 450 into your AC if you are using this command. After you bring it into your AC, what is the next thing you need to do? You want to add with number the number 4B. So it should be a 5451. You are doing the add operations. So it should be 5451. The first thing you bring in 15 into AC. The next thing you are adding 4B to AC add. After you add, what you do? You need to store back the values in AC to memory. So should be using this one, store. Should be 2, store back to which location? They say it's 450, right? The result is stored at 450. So 2450. Number to decimal, because all of them are in a hexa number in the figure. So using hexa number. Decimal. Just remain them in a hexa number. Should be your answer. How it the flow is your PC is 221. Then they bring in the 5451 into your IR. So the next one is 222. They bring in the instruction at 222 into IR. After they decode, they will bring the Okay, any questions on the flow? How's the flow of the instruction? Should be okay to write 15, but in a
the
final,
capacitor have
please at least must write all the
power
number.
inside
If it's
there,
zero, then put
so
zero there.
you
Zero,
become
zero,
logic
15 better.
logic 1. If capacitor don't have a power inside there, so it's logic 0. So DRAM, they use only capacitor and one transistor. So capacitor is analog device. Battery is analog device. It's not digital device. Okay, understand? That's why we call analog and digital. Question number 3. Ah, this one question number 3. You all computer science student takkan tak tahu. Question number 3.
Yeah, correct.
Some application for
Uh,
ROM. Anyone? For this one, in scope of internal memory. Internal memory. Anyone? Not external memory. Internal memory. Anyone? External memory kita ada CD-ROM, kita ada DVD. That one is a ROM. That one is external. Internal? Soalan nombor 4 je lah jawapan dia. They use for what?
in the pictures or the diagram, it's better to put 0015.
One of
Okay,
popular
don't put
thing about
15
the
hatch.
answer for question number 4 is BIOS lah. BIOS.
I think your friend mentioned
BIOS
one
is
error
right.
here.
In
here
terms
is
of you.
in here is 220, correct?
That's why
But in here
kalau you
should be
download,
221
you update
already.
your handphone.
Okay, since you have already
Update,
decoded and
they
you
say
already
ROM.
bring in the 15,
What
so here
version
should be
of ROM?
221 already.
Okay? Because
Okay,
you
here is
cannot
221.
you
In
cannot
your PC,
what
here
you
should
call
be
rewrite
221.
the ROM. Only manufacturer can
Okay,
rewrite
then
the
this
ROM.
one is correct. 221,
Okay?
they bring in
That's why
the
we call
221
ROM.
instructions. So here also the
This
same.
is point
When
of
they
view.
start to execute already, here should be 222. Okay. Then here will be a 223. Okay. So there's only 3 error here. The program counter. They are always pointing to the next instruction to be executed. Okay. Any questions? Clear? If no questions, then we go to the next question. Yeah, they ask you to give explanation. The answer is given in Malay. So the accumulator is to hold the to hold a data only. They are just holding a data to be processed. Okay, your accumulator. Then your program counter is holding the address of the next instructions. Okay, of the next instruction, the current instructions to be decoded. And then your memory address is the MAR. Is the address, is the register to hold the address to be read or to be written. Okay, you want to store something or want to load something from memory, the MA is the one who holding the address location. Okay, so let's say you are bringing something from the memory or want to store something back to memory, the memory buffer is the one to hold the data to be read or to be written. Okay. So the explanation is I translate to English. The PC is holding the instructions, the address of the instruction to be executed in the memory. Then the content inside the in the address holding by your PC will be sent to MAR. Okay, the address in the PC will be sent to MAR. Okay, then the address MAR will be sent to memory. So your PC is holding the instruction address. Okay, so it will send it to MAR, the one who holding the address which you are going to access. Then the MAR will send this address to memory through the address bus. When your memory receive this address, then they will go to the address locations and send the data to your MBR. Okay, your MBR will hold the data. After that, your MBR will send it to IR. Okay, so this is through data bus. So this is the whole process of instruction execution. I will upload this video recording in the spectrum after this. So clear, any questions? If no questions, then we go to the next one. The next one, questions 2. So here is the answers. They ask you to compute the number of clock cycle and execution time for the program above. So there's the formulas. Total clock cycle is the sum of individual instruction counts multiplied by CPI. So just simply this one multiply this one, and then sum them up. So this should be your clock cycle answers. Then your execution time is just using the total clock cycle divide by your clock rate, 2 giga. So the execution time is 68 millisecond. Okay, any question on this one? No, no, then we go to the next one. They are asking how much we need to improve the CPI of arithmetic and logic if we want the program to run 2 times faster. Okay, so this is your old execution time, the one you get from here, 68 millisecond, right? So they want them to run 2 times, get 34, right? So the new execution time should be 34 millisecond. Then you need to calculate the clock cycle for 34 millisecond. You're just using this formula. Inverse this formula, okay? The execution time equals to a clock cycle divided by the clock rate, right? So now you have the new execution time, which is 34. Then the clock rate is a 2 giga. Right? So you get your clock rate equals to 68. After you get a 68 mega, using back this formula again. So the rest is the same. 6 times 6, 1 times 4, 2 times 3. Only this one. 30 is remain, but this one should be a new values. Right? So just arithmetic should be equals to 0.73 for you to faster the program execution 2 times. Any questions? If you want to round up, also should be a 0.73. Yeah, 7 should be 73, right? 0.73. If you round it up, should make it 73, not 74. In fraction also can. No problem. Because the question asking how much much must we improve the CPI of arithmetic logic? So they just want to improve the arithmetic logics only. Okay, so that's why we only change the arithmetic CPI only. Okay. Then the final questions. They ask how much is the execution time of the program can be improved. So this time they changed the they already improved the CPI for arithmetic logic, all of the instructions. Then they're asking you the execution time. They reverse the process. So they're giving you arithmetic and floating point instructions is reduced by 40%. Reduced by 40% means it's just using 0.6 multiplied by arithmetic and floating point. Okay, arithmetic and floating point multiply 0.6. You get 1.8. Okay, both also getting 1.8. Then they mentions the load, store, and branch is reduced by 30. So multiply by 0.7, right? Reduced by 30%. So what the thing left is 70%. So 0.7. 4.2, this one is 2.8. Okay, so this is how you get the new CPI. Then you redo again the process in the question in the question 1. Same, using the same formula and same methods. Just using the new CPI here. Okay, then you will get your execution time is 42.8 millisecond. You write the factor in which the CPI need to be improved. So I mean the speed up then you are giving the ratio of the improvement, right? For the questions, right? The factor in which the CPI needs to be improved. Can also, but the question is asking you the new CPI values, right? So you must give the new CPI value. They didn't ask for new CPI values. Yes. So you can write the factor has been improved in the CPI. Yes. Then CPI is smaller than 1 is decreased. Yeah, the CPI is decreased means they require less CPI, less clock cycle per instructions. So mean your program is faster already. Before this, when you run one arithmetic instructions, they need how much instructions? How much clock cycle? Before this, the arithmetic is 3 clock cycle. They need 3 clock cycle. So means they need to have a 3 clock pulse. 1, 2, and 3 clock pulse. Only they can finish the instructions. So now they reduce it to 0.73. So if they even need the time less than 1 clock cycle, they can finish the task. So it means your program will be faster, has been improved. The program execution speed. Yes, I think you need to give the divide the new with the old one. Yeah. So at the end you should divide the new and the old one, because they're asking how much. A Don't need give the how much. You just give 0.3, or you want to give ratio also can. Both also correct. I don't think you need to, if you stop at here also correct. If you just stop at here giving the new CPI, should be correct also. If you give the improvement also can. Both answer also can. Okay, yeah? Oh, okay, yeah, in these questions too. If no questions, we go to the next one. Your final question. So this is your direct mapping. Based on figure 2, what is the address length in the cache memory system? Address length. So how we know? It's 24. From where we can know? Here is the address. Okay, when you refer to this figure, direct mapping, this part is the address. This part is the data. So this one is the address. So how many bits in the address? They are all in hexanumbers. So they have one hexanumber equals to 4 bits. So it's total 24 bits. So the address is 24 bits. Right? Yeah, they are 6 bytes. Not 6 bytes. There are 6 hexa numbers, not 6 bytes. Six hexa number. Okay. In here is a 6 hexa number. Okay. Byte, 1 byte equals to 2 hexa number. 1 byte is equals to 8 bits. So should be a 2 hexa number. Okay, then for B, how the address length is divided into tag line and a byte if the cache system has a 32768 line of cache. Okay, so this is the line of cache. So you need to 2 power of what equals to 32768. So it should be 15. So mean the line number is 15. So 15 bits required for line numbers. They told you total they have a 23768 lines in the cache. Right? So you need to know how many bits you required to assign to each, to point to each of the line. Okay, so you need 15. 2 power of 15 equals to this number. So you need 15 bits for the line. Then the word, how to get the word? How to get the word? How we get the word? From the data here. Okay. So this is considered one block. How many hexa number they have? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 hexa numbers. So 8 hexa number equals to 4 bytes. Okay. So they are equals to 4 bytes. Okay, 4 bytes. So 2 power of 2 equals to 4 bytes. One block equals to 4 bytes. Okay, and each location consists of 1 byte of data. Each location consists of 1 byte of data. So means 4 byte in one block. So you need 2 bits for the W. So 15 for line, 2 bits for blocks. Then the rest is for tag. 24 bits, right? Okay. Any questions on this one? No, we'll go to the next one. They ask you to put the tag and line numbers. So I just do one example here. The answer is given below. You can try to do it. 001 followed by 0011. This is a 1, 3, 5, 1, 2, 0010, 40100, 6, 0110. Right? Then just now they said, sorry, go back. Was asking tag and line numbers. Okay, 4 bits is for the 2 bits is for blocks. So this last 2 bit is for blocks. Then 7 bit is for tag. This 7 bit is for tag. Okay, so that's why your tag should be 001, 001. Okay, this is your tag, same as this one. Then from here to here is your line numbers. Sorry, the questions. Right, should be looking at the address, Right, you are right. This is the data. Correct. So this answer here should be wrong. Okay, we will do again here. So the first one should be 0, 0. Here is all 0 lah, right? I look at the data just now. But the way you do it is the same. Just refer to address. Okay, the answer for second one, anyone? 16004. I should look at here. Sorry, I need to delete this one. I look at the data. We should look at the address. So the first one address is this one. The second one address is this one. So it should be 001. Then 6 is 1, 0. And here is 0. Zero. Seven. Right, the number one should be this one, reduced to 6 hexa numbers. Number two is 0004. 4 is 01. Right? 1, 2, correct? We're looking at the address. So just now we look into isn't the line number equals to 15? Yeah, so it's 15. So I changed it to 15 already. Then write in hexa or binary. In hexa or binary should be okay. But prefer to be in binary. Okay. The most significant bit of address is 00 to FF doesn't mean the tag is 8 bits. No, we need to refer to how many bits the tag actually 7 bits, right? So it doesn't mean that we cannot look into the most significant. We need to know how many bits the tag required. Then only we can get the tag numbers. For question 3, your friend giving the answer, is it? Can you all check, is it correct? Number 4, anyone? Number 4, do you have answer? Someone do number 5. Number 4 is FF, so it's a 1111. 111. Followed by 0. Right, number 4 should be this one. Number 5. Number 5 is 1 and 6. Okay. IB. B is 101, correct? 3. And the last one is 4. Correct, correct. Check my answer. The last one is 4, right? So it should be 0, 1, 0, 1, the last one. 4, 9 number. Number 4. Okay, correct. Number 4 and 5. If you change to hexa, it's 0001. Number 2 as example. Uh, 000. If you put number 2 should be 1, 0, 0. Yeah, correct. Should be 0001. If you put it in hexa. Okay. Any other questions? If no questions, we will go to the last questions. Okay. Remember, just now I did something wrong. Refer to the address. See, not the data. Should refer to the address. Okay. When you do the tag numbers and line numbers. Okay. So we go to the last one. Last one, they're assuming the sequence of a memory address for. So they want you to provide the content for 160006. So it should be 160006. 160006. Understand? How to get 23? So we refer to this one. We refer to this block. This block is starting from 160004. So they told you one from this figure. Actually, they are telling you one locations they consist of 1 byte of data. Because you look into these two continuous block. I draw it here in 160000. The data is 77777777. Then the next one is 160004. Okay, so means 1600 location is consists of these values. That because in here they're telling you the 0 is at the LSB, the 1 is at MSB, right? So the 0 should be at here, so it's content here. Then the 160001 is pointing to this one. Then one values 160003 is this value, right? Then only 16004 is the next one. So from here we can also know one address memory locations consists of 1 byte of data, right? This is 1 byte of data. Okay. So now they're asking you 16006 should be consists of what data? So 16004 is pointing to 13, right? Then 16005 is pointing to 58. Then 16006 is pointing to 23. Right? Understand? Anyone have any questions on this one? How you get the data? No? No question. So FF97BD, FF97BD. Where is FF97BD? It's here, FF97BD. Okay? So the first one is BC. BC 33. What if a big endian? Why like this one? What do you mean by why like this one? Why from right to left, not left to right? Because they are in the questions they got telling you this one, right? Basically, this is the thing telling you this part. The sequence of memory address for byte access is in the follow. Okay, in the last one, followed by the location 1. Then the location 2 will be here, location 3 will be here if there's 4 bytes. Okay. Okay, if the inverse, they should be telling you this is 0 0, this is 0 1, this is 1 0, and this is 1 1. They were telling you in this form, but now they are telling you in this form. Okay, so that's why your address locations, the 160004 is pointing to this one at the last byte. Is this explanation clear? Okay. So this is little endian. The next the one we do here is a little endian. The inverse one is a big endian. Okay. So they are giving you the explanation here. Okay. So that's why your BD should point to a 33. Then the last one is a 166A9B. 166. Where is the 166A9B? Is here. Okay, your 166 A9B should be in here. 98 pointing to this one. 99, 9A. So this is your 9B. So your 9B is content data FE. Okay. Question 2, last subsection. Question 2. What do you mean by question 2, last subsection? You mean this one? The CPI question. Oh, okay, CPI question. I will add the video after this also, so you can refer back to the video. Question 2. This one. Any other questions? Three C. Three C. If I use 6 tag bit instead of 7 tag, that's correct. I don't think you get marks, because your tag number should be 7 bits. You're given 6 bits. Unless your line number is still correct, then should be okay. If both also wrong, then I think there will be no mark. Any other questions? If no questions, then that's all for today. Tutorial 7 not open? I will check. After that, I'll open. Yeah. Any other questions? Your mid-sem result. We are still marking. We'll let you know once we have done. Okay? Other than the assignment, they should have at least one more assignments in the lab. Okay? Tag at this line hexa number. Yeah. If it's correct, then you should get marks. If it's in hexa, no worry. No more handsome face. Okay. Due to MCO. Lab hard to understand. Just follow the video from in the spectrum. If you have any question, post in the spectrum. I will try to answer. Okay. If you have any question on lab, with line number equals to 7. Yeah, can. put 7 also can, I think can. You mean the question to divide how many bits? Yeah, if you set line number needs 7, I think should be okay. For question 3, question 3, you mean you put it in hexa number, but you didn't put H3C. Should be okay, but because but the exam better to put to inform is whether in hexa or what. Because if you do in hexa, I think your the other question will have ABC, right? So I think the examiner should be know that is hexa number. Okay, any other questions? So if no question, then that's all. That's in this question, yes, from the questions they already give you the address length in the pictures, so you can get the length from it, and they are telling you in hexa numbers. Okay. So no more question, huh? If in the questions they for sure they will use hexa number equals to 4 bits. Okay, so if they didn't mention anything, so just assume that is a one hexa number equals to 4 bits. Okay, so I think that's all for today. Selamat Hari Raya to all the Muslim students. Then next Monday, I think we don't have the lectures. Next Wednesday, we'll have tutorial sessions. Okay. So thank you and take care. Selamat Hari Raya.